In this video, we're going to be analyzing this Wheatstone bridge circuit with 5 resistors using Kirchoff's laws. The first thing we will do is we're going to realize that this circuit is not able to be simplified. Because we have this resistor here going between node 1 and node 2 here, these can't be simplified into parallel, and these cannot be simplified going into series. This means the circuit is in its simplest form already. The next thing to do is to label the currents, which I've already done. We have the total current coming from the voltage source. It splits out into I1 going through resistor 1 and I2 going through resistor 2. And at these nodes, each of I1 and I2 split into I3 going through resistor 3, I4 going through resistor 4, and then both split into R5. Now, we'll have a positive I5 going to the right, and we will put a negative R5 going to the left. This is just for convention's sake. We could do it the other way around, and the answer will be the same. We might get a negative answer for I5, which just means the current is flowing the opposite direction to which way I've stated, which is right. I've labeled V1 over R3 and V2 over R4. These will be helpful in finding I5. The first thing to do is get some equations for I5. We can use Kirchoff's current law to do that first. As we're going into this node from I1, it will split out into I3 and I5. So, I5 is equal to I1 minus I3. In this node, I2 is coming in, splitting into minus I5 and I4, or another way to think about it is I5 is coming in, and I2 is coming in, splitting out into I4, which we can write as I5 is I4 minus I2. I will label this top one equation 1, and this bottom one equation 2. Now we can make 1 equal to 2, because both of them equal I5, which brings us down to I1 minus I3 equals I4 minus I2. Now we can find equations for these currents. I3 is reasonably simple because I've labeled V1. I3 runs through resistor R3, which has a voltage of V1 over it. Using Ohm's law of V equals IR, or I equals V over R, we can say that I3 equals V1 over R3, and we can do this on the other side, saying I4 equals V2 over R4. The next thing we want to do is we want to find I1 and we want to find I2. And we can do this with Kirchoff's voltage law. First, we can do a loop around this loop, going through the voltage source, through resistor 1, through resistor 3. We'll have plus the voltage source, minus the voltage over R1, which we can write as R1, I1, minus the voltage over R3, which is V1, equals 0. We can rearrange this to put R1, I1 equals V source minus V1, I1 equals V source minus V1 over R1. We can do the same thing around this loop with R2 and R4 instead of R1 and R3 to get I2 is equal to voltage source minus V2 over R2. Now we can substitute all of these I values back into this original equation. We have I1, which is Vs minus V1 over R1, minus I3, which is V1 over R3, equals I4, which is V2 over R4, minus I2, which is V source minus V2 over R2. We will call this equation 3. Remember, this still is I5. It goes to I1 minus I3, which is equal to 5. And the same thing on this side, this is also I5. Another way to find I5 is with Ohm's law, where I equals V over R, so I5 is equal to the voltage over R5, which I will label as V3, over R5. We can use Kirchoff's voltage law around this loop, clockwise, with V3 going this way, which is positive, as I've done the current going that way. So we'll have V3 plus V2, as it's positive again, minus V1 equals 0. We can rearrange this as V1 equals V2 plus V3. Now, V3 is actually I5, R5. So we have V1 is V2 plus I5, R5. Now that we have this equation, we can substitute this, which we previously said was I5, into I5 here in order to remove an unknown, to have V1 and V2 be the only unknowns in this equation. V1 equals V2 plus brackets V2 over R4 minus V source minus V2 over R2 R5. Now we have an equation for voltage 1. What we can do with this V1 is we can now substitute it back into this equation, here and here. When substituting in, we want to take the V1 out of this fraction in order to not get fractions within fractions, which is hard to read. So we'll split it out into Vs over R1 minus 1 over R1, and then this will be VA1, which is V2 plus V2 over R4 minus V source minus V2 over R2 times R5. Then we will have minus V1 over R3. We'll do a similar thing by doing minus 1 over R3 times V1, which is V2 plus V2 over R4 minus V source minus V2 over R2, close, R5. So that's the bit on the left, which we will then make equal to V2 over R4 minus V source minus V2 over R2. Now, what we have here is an equation which has a singular unknown, V2. We will know V source, we will know R1, we will know R2, we'll know R3, we'll know R4, and we will know R5. So what you can do with this equation is you can solve for V2, and then once you have V2, you can substitute back into this equation here, sub back in, and you can find V1. And then once you have V1 and V2, you can go back to here to find I5. Now, let's look at an actual example with numbers. All right, here's a circuit with some numbers. We have 12 volts from the source. R1 is 24 ohms. R2 is 33. R3 is 80 ohms. R4 is 56. And R5 is 44 ohms. Now we can substitute those numbers back into this equation in order to find V2. Before we do that, we should simplify this equation a little to make it easier. The first thing to do is notice that this set of brackets and this set of brackets are the same, so we can factorize by taking it out as a factor from this term and this term. This can be written as the source over R1 plus minus 1 over R1 minus 1 over R3, which are these two. And then this set of brackets, which is V2 plus V2 over R4 minus Vs minus V2 over R2 R5 close bracket. That then equals this. The next thing to do is start substituting some of the numbers in, not substituting all of them, in order to do it simply over multiple steps instead of painfully over one step. We'll substitute into this term, this bracket, and this side of the equal sign for the first step. On this side of the bracket, we have V2 over 56 minus 12 minus V2 over 33. That is equal to 12 over 24 plus minus 1 over 24 minus 1 over 80. And then this whole bracket will go in here, but I'm not writing that right now. The next thing we'll do is we can expand this bracket and we can add the values in this bracket. We'll have V2 over 56 minus 12 over 33 plus V2 over 33. And we'll move this 12 over 24 to the other side of the equal sign. So it's minus 1 over 2 equals minus 1 over 24 minus 1 over 80 is minus 13 over 240. In the bracket, I'll also substitute the values in. So we have V2, because we still don't know what that is, plus, and I'll put R5 at the front because it is easier, so 44 times V2 over 56 minus 12 minus V2 over 33. The next thing we can do is expand all of these brackets and add these together. So minus 12 over 33 minus 1 over 2 is minus 19 over 22. And V2 over 56 plus V2 over 33 is 89 V2 over 1848 equals minus 13 over 240 V2 plus 44 V2 over 56 minus 12 over 33 plus V2 over 33. And then we can continue down with minus 19 over 22 plus 18 9v2 over 1848 equals minus 13 over 240 v2 plus 44, and we'll add these. v2 over 56 plus v2 over 33 is the same as over here. 89 v2 over 1848 minus 12 over 33, and then again minus 13 over 240 v2 plus 44 times 89 over 1848 v2, which is 89 over 42 v2 minus 16. And then I'll just put the other side down here. And now we'll add the v2s inside the brackets. So this will just come down. We'll have minus 13 over 240. 1 plus 89 over 42 v2 is 131 over 42 v2 minus 16. And then finally expanding the bracket, we'll have minus 19 over 22 plus 89 v2 over 1848 equals minus 13 over 240 times 131 over 42 is minus 1703 over 10080 v2 plus 13 over 240 minus 16 is 13 over 15. Continuing, the final thing we've got to do is move the v2s onto one side and the numbers on the other. I'll move the v2s to the left because that's where they're positive, and I will move the numbers to the right because that's where they're positive. So 89 over 1848 v2 plus 1703 v2 over 10080 is 3439 v2 over 15840. And on the other side, 13 over 15 plus 19 over 22 is 571 over 330. Now, in order to get v2, we just have to divide both sides by this fraction. So v2 divided by it is v2, and 571 over 330 divided by 3439 over 15840 is 7.970 to 4 significant figures. I will keep the full value in my calculator because we still need to calculate v1 and then use both of these values in order to calculate I5. Now that we're at this step in the process where we've solved for v2 being 7.97, we can now substitute back in to this equation to find v1. We've got the v1 equation here. v2 is 7.97 volts. So v1 is going to be 7.97 plus 7.97 over 56 minus 12 minus 7.97 over 33, and then that is all going to be multiplied by 44. Putting this into a calculator, v1 has a value of 8.858 volts to 4 significant figures. Again, keeping this in my calculator with the full unrounded value, we can go back to this equation here, and we can find I5. So v1 equals v2 plus I5 R5. V1 is 8.858 volts. V2 is 7.970. R5 is 44 ohms. We can rearrange this to be I5 R5 equals V1 minus V2. I5 equals V1, which is 8.858 minus 7.970 divided by R5, which is 44. And with this, we find that I5 has a value of 0.02019 amps to 4 significant figures. That is our answer. Now, we have a positive answer. This is positive. And that tells us that in the original circuit, I5 being positive means that it is in fact running this way. The current is going from the left to the right in the direction that we stated was positive.